Hello students, today I am going to explain to you how the temperature influences the reaction rate. Okay, temperature has a great influence on reaction rate. When temperature increases, the reaction rate increases. The reaction rate and the value of a rate constant becomes double for every 10-degree rise in temperature. Okay, the influence of temperature on reaction rate can be explained on the basis of two theories, collision theory and transition state theory. In this video, I am going to explain to you how temperature increases the reaction rate, that is the influence of temperature on reaction rate on the basis of collision theory. Okay, collision theory. Okay, we have learned that the basic requirement for a reaction to occur is that the reactant molecules must collide with each other. That means this is the basis of collision theory. According to collision theory, collision between reactant species may be atoms, molecules or ions, leads to chemical reaction. Okay, then this is the basis for collision theory. According to the collision theory, the reactant molecules are assumed to be hard spheres, and the reaction takes place due to the collision between the reactant species. The number of collision that occur per unit volume of the reaction mixture is called the collision frequency. The collision theory introduced a term, collision frequency. Collision frequency symbol is such. It is the collision frequency means what? It is the number of collision between the reactant species per unit volume of the reaction mixture, and the collision which leads to the formation of the product. The collision which leads to the formation of the product is called effective collision. That means only effective collision leads to chemical reaction. Okay, then the two important barriers for effective collisions are, number one, energy barrier. Number two, orientation barrier. Yes, the reactant species have to cross these two barriers. That is energy barrier and orientation barrier. Then only effective collision takes place. Okay, due to the effective collision, the bonds between the reactant species may break and new bonds are formed. That means we will get products. Okay, then let us see the first barrier, energy barrier. For reacting species to make effective collision, they should have sufficient amount of energy to break the chemical bonds in the reactant species. That means the reactant species must possess a certain minimum amount of energy to break the bonds between the reactant species, which leads to the formation of the product. Then this minimum amount of energy, the minimum amount of energy, the minimum amount of energy possessed by the reactant species to bring about a chemical reaction is called threshold energy. Yes, collision theory introduced a new term, a new concept, that is threshold energy. What is meant by threshold energy? It is the minimum amount of energy required by the reactant species to bring about a chemical reaction. This means that only those collisions of reactant species will give a product which possess the minimum amount of energy, that is threshold energy. That means the reactant molecules, which only those reactant molecules which possess this minimum amount of energy undergo this effective collision. Okay, due to the effective collision, the bonds between the reactant species may break and new bonds are formed. That means we will get products. Okay, then yes, the next barrier is orientation barrier. Okay, let us discuss about this barrier. Orientation barrier. Orientation barrier. Okay, the colliding molecules should also have proper orientation so that the old bonds may break and new bonds are formed. That means in order to take place chemical reaction, the reactant molecules must possess the minimum amount of energy, that is threshold energy, and the reactant species should have proper orientation. We can explain this concept on the basis of a simple reaction, this orientation barrier. Okay, please listen. NO2 gas, two molecules of NO2 gas combines together to form N2O4. Okay, NO2 gas, two molecules. One molecule of nitrogen, yes, one nitrogen atom, and two oxygen atoms are present in one NO2 molecule. NO2 plus NO2. NO2. Yes. In this case, two nitrogen atoms combine together like this. Nitrogen, nitrogen, okay, oxygen, 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 oxygen. Yes, here the two molecules approach each other, and this orientation is proper orientation because here the bond is formed between two nitrogen atoms and forms a bond between two nitrogen, and you will get the product N2O4. This collision must will be effective, and you will get the product N2O4. You will get the product N2O4. Okay, this is the proper orientation. This proper orientation leads to effective collision. Effective collision leads to formation of the product. And the next type orientation, yes, like this, N2 oxygen, NO2, NO2 plus like this, or then NO. This orientation is not a proper orientation. Here, when two NO2 molecules approach each other, the molecules repel each other, and you won't get the product N2O4. No product is formed. Okay, the first type of orientation is proper orientation. Then we can conclude the class. According to collision theory, only effective collision breaks the bond between the reactant species. For effective collision, the reactant species must possess threshold energy and minimum amount of energy, threshold energy and proper orientation. When temperature increases, please listen, when temperature increases, the number of molecules acquiring the minimum amount of energy, threshold energy increases. That means more reactant molecules can cross the energy barrier, and effective collision takes place. The rate of chemical reaction increases. Okay, my next video, next video I will explain to you about the effect of temperature on reaction rate on the basis of transition state theory. Okay, goodbye.